And welcome, Mindsetters, to this grade 11 live Learn Extra session. Guys, I hope you're nice and ready. Hope you guys have got your pens and pads out. Make sure you guys are making notes, because the lovely Dina is going to be telling us what we're going to be doing today.
Well, before I tell you what we're doing, I just want to say hi, Mommy. Happy birthday. Hope you have a good day.
Hi, Dina's mom. Happy birthday.
And then just for everyone watching, we are going to be looking at a revision of functions, specifically algebraic functions, something about the straight line, something about the parabola, the combinations of those. So Ty's already said you need to have your paper and your pencil, but you need your blanket and your hot chocolate because it's mighty cold out there.
Exactly. Okay, so while Dina makes her way there, and by the way, Dina, hair looks awesome. I'm loving it. So guys, make sure, as I said before, pens, pads, you guys are making notes. Guys, I cannot stress enough. Make sure you get on the page and get chatting to us, because I also have this Casio calculator and labeler to give away. Guys, make sure you get chatting to me on the page, because on top of that as well, I have this awesome maths learner book. See, for winter school programs. Guys, these books are so awesome. Like, I've been going through some of them and they really are helpful. Like, I wish I had these when I was doing my high school. But guys, I cannot stress enough, make sure you get posting, because I have a lot of these to give away. And when I mean a lot, we've got boxes in the offices. So guys, make sure you post. And I always say, tell a friend to tell a friend to tell a friend, to make sure that they get on the page. Guys, set up study sessions, whatever you can, to get as many people on the page, even all of you. If you guys are on together studying, make sure you guys have all your phones out and you guys are Facebooking, and make sure you get those questions in if you're lost anywhere. But for me, I'm going to get off my little soapbox and hand it over to Dina. Dina, take it away.
Thanks, Ty. Good to be with you. As we said earlier, we're going to look at functions, specifically algebraic functions, and how to deal with when you're given a diagram, as well as how to deal with perhaps sketching a diagram. So I'd like to take you to the core of what you will be seeing in your final grade 11 paper, which is often a combination of a parabola and a straight line, or sometimes a hyperbola and a straight line, sometimes an exponential and a straight line. But there's always a straight line function somewhere lurking in the background there. So I'm going to take some examples from previous exam papers as part of the revision of this function session, and so why not take down the diagram that's on the screen that you will see now. Firstly, we've been given function f, which is your quadratic function. We've been given function g, which is your linear function, and we will need to work out a few things on the function, but I'd like you to take some of the key points that you've been given, and that is that this turning point is called P, and its coordinates are 1, 8. F's y-intercept is at 6, and we have also that this line's y-intercept is -1. So you need to have that down, otherwise you can't accompany me without that diagram. So the x-intercept is A, the x-intercept is B, and then we have this C, which is another point of intersection of F with G. So those are the key points: turning point, y-intercept 6, x-intercepts of A and B. The straight line is sharing that x-intercept, and it intersects the straight line, and it intersects the parabola at C, and then we've got that y-intercept of -1. Okay, let's have a look at the questions. We've got, firstly, we'd like to find out what the equation of f is. In other words, what's the equation of the parabola, the equation of g, which is the equation of the straight line, and then we'd like to find out what the coordinates of c are, and we've also got, if h is f minus x, what would the equation of h be? Okay. Right, so some detail around the parabola is to find its equation. What is the equation of the parabola? And if you had to ask yourselves, if you were with that situation of finding the equation of the parabola, what would you do? Where would you begin? Well, you need to identify what are my formulae for the equation of the parabola. And there are two separate equations of the parabola. One you'll be very familiar with, that is the squared format, and the other one would be the x-intercepts. And I'm going to look at both of them, and then we're going to make some decisions as what we think would be most efficient to use in this particular example. Okay, so if we look at f, and we look at the given information, straight away we are guided over here by seeing that this is my turning point. So if this is my turning point, I'm going to be guided by the fact that I need my turning point formula. So since we are doing a revision lesson today, let's look at the equation of the parabola in terms of reviewing what the various formulae are. So the equation of parabola comes in two formats. We're either going to have the format where y equals a into x minus p squared plus q, or we have the format where y equals a into x minus alpha, x minus beta. And we speak about this format as when we have the x-intercepts, and we speak about this format as when we are given the turning point. So two separate equations, one when we are given the turning point, one when we are given the x-intercepts. And if you look closely, we have been given the turning point in our graph. We've been given the point P18. So we have the information that P and Q have been given. So that's where we would begin. And in both these equations, you are given something. So in this one, you're given the turning point PQ. We can actually say we've written PQ. So we have this turning point here as being PQ, and then over here we've got the x-intercepts as being alpha and beta. Okay, but since in this equation we're given the turning point, we're now going to utilize that equation. So we have the turning point as P18. So we're substituting P as 1 and Q as 8. So therefore, y equals to a into x minus 1 squared plus 8. Then what's missing is the a, the coefficient of that squared bracket. And in order to get a, we need to substitute an xy point. So we go back to the graph. I'm going to go back to the graph. Which other point am I given? Well, I don't know C, I don't know A. There we go. We know this point here is what? 0, negative 6. So I can substitute that point 0, negative 6 into my graph. So I'm substituting an xy value, which is 0, negative 6. And therefore, y is negative 6, x is 0, and I now can solve for a because now I've got one variable. So my equation started with 2 and 2 variables, so with the 4 variables, but I've been able to replace them and only get an equation in one variable. So if I solve for a, I'm going to get minus 6 is equal to a plus 8, which is going to give us an a value of, well, let's just correct this. This is actually positive 6. So right, so minus a, which is going to give us an a value of minus 2. So we now go back to this first equation we set up, which is f of x. It was in the f form, its function f is minus 2 into x minus 1 squared plus 8. And so that is my equation of the parabola, and it's in this form, in this quadratic form, so I could multiply it out just to see what the various coefficients of the various terms would be. Minus 2x plus 1 plus 8. So we get minus 2x squared plus 4x minus 2 plus 8. And that's minus 2x squared plus 4x plus 6. And what's wonderful to see is that our graph had a y-intercept of positive 6. And as we've multiplied this out, we're getting a x-intercept of or a y-intercept of positive 6, which makes me think that this one is perfectly accurate. Okay, so that would be the equation of of the parabola. Okay, so we've been able to find f, which is our parabola. Okay, so remember it's got two equations, either the turning point or the x-intercepts. Then G is actually our straight line. And we're now saying, how can I find the equation of the straight line when I only have 1 point? That's not possible to find an equation with 1 point. I need more information. So if I go back to the line and I start asking myself, well, do I know something about C? No. I only have its y-intercept. Do I know something about B? Well, I don't know anything about B at this stage, but I certainly can look deeper and see that B is the x-intercept of my parabola as well as A. And so they share, that line and that parabola share that x-intercept at B. So if I can calculate B's coordinates, then I've got that as a second point for my straight line. And then I'm home and dry, then I'm sorted. So let's go and work out what that equation is. So we've got our straight line as having the following information. Firstly, it's called G, function G, and it has the point 0, negative 1, and it also has point B, okay, and it's the point x of B and 0. Okay. And this point happens to be the x-intercept of that function f as well. So to calculate point B, I'm going to say that that's where my y value is 0, because that's my x-intercept. And if I do that, then I'm going to get an equation, a quadratic equation, equal to 0, which I can now solve. So if I have minus 2x squared plus 4x plus 6, how could I solve that equation in the quickest way? Well, you certainly could use your quadratic formula because it's quadratic in nature. But if you notice, it's got a common factor of negative 2. And because I've got a 0 on the right-hand side, and I divide by this negative 2, I can now say that would be x squared minus 2x minus 3 equals 0. And can you see now that becomes quite easy to factorize, because it's x minus 3, x plus 1 equals 0. And if we just test, minus 3 plus 1 is minus 2, so we get a negative 3. So therefore we're saying that x is equal to 3. It could be 3, or it could be negative 1. Now remember that these values are the x-intercepts of that parabola. So there are two of them, which makes us have to choose x is 3 at B because it's on the positive side, and x is negative 1 on the negative side. In other words, we're actually saying that x of B is minus or is 3, and x of A is actually minus 1. Let's go back to the diagram and see whether it makes sense for these values. So we're testing them. Does it actually make sense for these values? So we're saying that at A we have a negative 1, and at B we've got a 3. Does it work to have these x-intercepts? Well, let's see. The distance from A to O is 1 unit, and from O to B 3 units. So there are 4 units from either point across this axis of symmetry. Okay, which means that since the graph is symmetrical about its axis of symmetry with the x-intercepts, it would then make that each of these points is 2 units away from the axis of symmetry. So if I take 2 units away from 3, I get to 1, and if I add 2 units on there, then I get to 1. So it certainly does make sense. They match the fact that the axis of symmetry is at 1. Okay, well that's good. We've now got that, that's the x-intercepts. How does that help us? Well, we've now got, remember this straight line over here, we've got 1 point, and we've got now the second point. So what can we do on a straight line if we have the point 0, 0, negative 1, and we have the point 3, 0? What can we do with 2 points for a straight line? So on a straight line, we can work out what the gradient is. And the gradient would be 0 plus 1 divided by 3 minus 0. So change in y over change in x to work out what the gradient is. And so we've now got that gradient is a third. So my g of x, which is my straight line, is now going to have a third x. And do you remember what the y-intercept was? Remember where that straight line crossed the axis? It was at -1. So there's my equation of my straight line. Okay, so I've now got the equation of the parabola. I've got the equation of the linear function. Let's carry on and see what our next question is. Okay, so we've got the straight line. We've just done that. Now we need the coordinates of C. Okay, let's go and have a look at what's happening at C. What is going on here? Well, I definitely see that the one graph is intersecting the other graph at C. And all that we're saying that's happening at C is that for that x value on the line, which is the same one as the parabola, the y value of the line and the y value of the parabola are exactly the same. So if I took another x value to the right of this orange point, I can see that at this x value, my y is actually bigger than the y over there. So at this point here, x's are the same, y are the same. So we talk about them intersecting. Algebraically, what does that mean? On the picture, visually, I see that they intersect, and therefore their x's and y's are the same. But how would we work that out algebraically? How do we connect the picture's intersection to an algebraic intersection? Okay, so that's what we're interested in, is to go and find out how do we work out points of intersection. Okay, points of intersection. Okay, these are calculated algebraically as the point where, so we've got f of x's equation and g of x. And we can see from above there that g of x was a third x minus 1. And this one was minus 2x squared plus 4x plus 6. Let's just confirm that. Plus 6, yeah. So that's correct. So those are the two. Algebraically, for us to be able to work out those points of intersection, we're going to say that f of x is equal to g of x. Okay, so we're going to work out when the y values are the same. Please tell me what is happening with x. So we're making the y's the same because that's what we see on the picture. Okay, and then we get that minus 2x squared plus 4x plus 6 is equal to a third x minus 1. Right, what would you suggest us do with a fraction? What would you suggest? I think I'm hearing you from where you're sitting. We would multiply by that common denominator. So I would get rid of the fraction by multiplying by 3. So we would get negative 6x squared plus 12x plus 18 is equal to x minus 3. And then that would give us a minus 6x squared. This x comes across this way, so that's plus 11x. And this 3 comes across this way, so that's plus 21 is equal to 0. Okay. And then I sit with this quadratic. So I'm just going to change signs and see if anything nice happens here. Minus 11x minus 21 is equal to 0. Now I've got to find factors of 6 and factors of 21 that will actually give me an 11. So I'm just going to play 3x and 2x. 7 and 3. Shall we go with a 3 and 7? So that's 14 and 9. That doesn't really work. So we need to go 3 and 7. Let's see if that works. 21 and 6. Doesn't really work. Okay, let me then just go back there. Can't see what the factors are. Maybe they're 6 and 1 and 7 and 3. Let's test 6 and 1 and 7 and 3, or 3 and 7. So we've got 18 and 7. Oh, that's good. So we've got a 6x and an x, and then we've got a 3 and a 7. So we've got a negative 11, so therefore we want a negative 18 and a positive 7. So we get x is negative 7, 6, or x equals 3. Okay, and if we just go back to what the question asked, it said, what are the coordinates of C? So we've now found that the x value at C is minus 7, 6. We haven't yet found what the y value is. And this technique of actually going back to seeing what the question is very important, because remember, we took quite a long time to work out what that solution to that simultaneous equation was, and we then get maybe sidetracked and think, oh, we've just finished the question, and we actually haven't, because it said, what are the coordinates of C? We've only found the x value. How would we find the y value? We would take this and substitute into y equals 1/3 x minus 1, and that would give us a minus 7/18 minus 18 over 18, so we would get minus 25/18 as our y value, and therefore C is the point negative 7, 6 and a negative 25/18. Okay, Ty, I think we'll take a short break.
All right. So guys, make sure you don't go anywhere. And guys, I'm loving what's happening on the page. I'm seeing you guys posting, which is awesome. Guys, keep posting. And if you're lost anywhere, make sure you write where, like if you need help, just make sure you write up the question or wherever you need, the section that you need help on, and then we'll make sure that we look at it. But guys, I also want you guys to post because we have these to give away. And I have also this book to give away. So make sure guys, you get posting, and this will be awesome for your winter school sessions that are coming up real soon. But for now, guys, we're going to see you after this break. Welcome back, Mindsetters. I hope you had a nice little break. You went and got your snacks, whatever you needed, so you don't get distracted, so you guys can make sure that you guys go nowhere. Because yes, I still have this Casio calculator giveaway and this labeler and this awesome winter school maths book. And talking about winter school, grade 11s, I've been hearing a lot of you saying, oh no, it's winter school only for grade 12s. No, it's sessions for you too as well. Your guys' winter school starts from the 9th to the 12th of July. And guys, there's also going to be Saturday schools as well. There's going to be 2-hour shows and 1-hour live shows. And guys, there'll be so much people on the page, so make sure you guys get chatting to each other, help each other out, because that's why the page is there. But make sure, guys, for this session right now that you're paying attention, you've got your pens, pads out, and you're working along with Dina, because it's so helpful when you're doing revision. So guys, I'm actually going to hand over to Dina. Dina, take it away.
Thanks, Ty. Well, I've told you before that this is going to be one of your final questions in that grade 12 paper. It's waiting for you because it's one of the key components of the syllabus, being able to work with quadratics and linears. So I showed you an example earlier of how to work out the equation of the functions and working with some points of intersection, and I'd like to show you another question that's come from a past paper, and you'll see the repetition of some of the questions, but also the introduction of 2 new concepts, the vertical distance as well as working with the horizontal distance on these graphs and how to work out various aspects of those lengths. So let's get right to it. Everybody, if I can ask you to just take down the diagram, because as I said earlier, it's very difficult for you to try and answer questions when you don't have the diagram. So the diagram again has got a function f, which is my parabola, and it's got a straight line, which is g. And f has got that equation, negative 2x squared minus 4x plus 30, and g of x is 2x plus 10. And we've been asked for various coordinates, but let's just look at it firstly. We've got A, G, C, the y-intercept, D, the y-intercept. We've got E as an intersection, and then we've got this J, K, L that's parallel to the y-axis. And then we've got L, which is this point here, and I think that's about it. So you've got A's and B's as the intercepts, C's and D's as the intercepts, E as the intersection, and we've got this GH G being the turning point of that graph. So we can't just assume these things. We've actually got to be told what they are, and certainly it's a turning point. Okay, so we want to find out some coordinates. We want to find some x values. Coordinates of E, that's again the point of intersection. I may just not do that one. We'll see how it goes. And then we've got GH as a vertical. And then when you are given that JL is 60 units, how long is the value of OK? So let's not make anyone move around, and let's go straight to it. Okay, right, coordinates of A, B, C, and D. Well, if we have a look at the figure, and you wanted to find out those 4 coordinates, which 2 would you straight away start with? Because they're actually given to you. You don't have to actually go looking for them. They're actually staring at you. Okay, so we've got C and D as our y-intercepts, and we know that if a function is given in standard form, that if I make x 0, because that's where the y-intercept occurs, then my constant is actually that y-intercept. So I don't have to go very far to say, hang on, this value here is 30, and this value here is 10. Okay, so coordinates of C and D are straightforward. And an exam technique would be, because the examiner is asking you in a certain order, doesn't mean always that the order gets trickier or more difficult. It could be that there's some questions within that order that are easier to work with, and you can certainly start with those. Okay, and then we go off to A and B. And what are A and B? They're the x-intercepts, so let's go straight to those. The x-intercepts of this function here, let's remember that minus 4x, okay? Otherwise, if we don't remember that, we can't do anything. So first question would be the x-intercepts of f of x equals minus 2x squared minus 4x plus 30. And that happens when the y 0, so that's minus 2x squared minus 4x plus 30. Again, it's a quadratic. Make it nice and simple. Divide by negative 2 on both sides. So we get a 0 equals an x squared plus a 2x minus 15. And if we factorize this, this would be an x plus 5, x minus 3. So we would get an x of minus 5, or an x of 3. So those are my x-intercepts. Great. So we can come back here, and let's just fill them in on the picture, minus 5 and a 3 here. Right. Now, as you're going along, don't just calculate things and just kind of be oblivious to what else is around you. Try and make some connections to those values that you've just found, especially the x-intercept. If I found the x-intercept, look what happens now. OA is 5 units, OB is 3 units, so there's an 8-unit distance between those intercepts, which means what is that midway point? Well, that midway point is going to be 4 units from either one of these, so it's going to be at minus 1. So I already know that the turning point has got an x value of minus 1. Can you see how great that is? So if I now go and check the formula, and since we're doing revision, let's see what the revision point is for the turning point. What is that formula that we know? And it will be on your formula sheet. That x equals minus b over 2a. That's the turning point's x. And minus b would be positive 4 over 2 times negative 2, which would be negative 4. So it would be a positive divided by negative, which would give you a negative 1. So it's certainly confirming what you had already decided to work with, because you were given those values. So I can find out what the next thing is by being given those values. Right, so that was the turning point. Now, question to you is, if g's x is negative 1, how would you calculate the y? There are a number of ways of calculating that y. But one of them would be, since I've got the function value, I could say f of minus 1 would be what this value over here is. So we could say that this value over here is really a minus 1 and an f of a minus 1, which I can calculate. Okay, let's try and do it in our heads. So if we have a minus 1 squared, and we have a minus 1 over here, then can you see that I've got a minus 2, and I've got a positive 4 here. So 34 minus 2 would be 32, and does it make sense for this value to be 32? What can you compare it to? You can compare it to this 30, and this is certainly 2 units higher, so it makes sense that that's 32. So I'm going to write that up there. Let's just erase this function value here, and let's write in here that this is certainly 32. So I've been able to work out what that turning point is without completing the square algebraically on that function. And that's very a powerful thought, that you don't always have to go with the same method. You've got to go with the method that perhaps is most efficient, so you don't land up doing all this algebra and wasting time and not getting to the end of that question. You've got to have some think time and think through the efficiency. And the only thing that led us to that was that we have the x-intercepts. When we've got the x-intercepts, we've got that axis of symmetry, and if we've got that axis of symmetry, we can just substitute it in, and it was unnecessary for us to complete the square. Completing the square takes forever, so I would not go there. Right, so that would be our G, which we weren't asked for, but we certainly can work on something a little later. So we've got A and B. And with this one, we'd like to find out what is x. Okay, what is x so that f of x is greater than 0? And I find that a lot of people battle to read that. And basically what this is saying is, when is my y of f? When y of f is positive. That's how you read this. Okay. Now think about it. If you say y is positive, immediately what comes to mind if you say y is positive? Well, I'm thinking of all those y values above the x-axis. That's where they're positive. So that's what you're going to go and do on your graph. You're going to go to where y is positive on the graph. Okay. And you're going to color that in. So I'm going to take positive y. There it is. Okay. Those are all y's that are positive for that quadratic function. Below the x-axis, they're all negative. At A, at B, y is 0. So you have a boundary. 0 values, positive values, and negative values. The question says, please find x if you're given all these pink values. Okay, well, let's start. What is x at A? It's negative 5. And what happens is you move to the right. It gets bigger and bigger and bigger. It gets to 0. It gets bigger until it gets to 3. So if I substitute any value from negative 5 to 3 into my f, I'm going to get a positive value, a positive value, a positive value, etc. So any value between minus 5 and 3. So the answer to this question would then be that I can have an x that is between 3 and minus 5. Choose any x in that range, and I will get a y value that's positive. Notice I haven't included those values because at those values we've got the 0 case. Okay, right, so then we've got coordinates of E. Again, I've taken this as an exam question, so that's how it was posed. E is that point of intersection. I'll come back to it at the end because we've already done one of those. Let's rather go into a more interesting question, which is the length of G of H. And if JL is 60, we need to find OK. So these questions are going to keep us busy for a little while, and if we have time at the end, we'll come back to coordinates of E. For those of you that are on top of it, certainly can post your answer. What are the coordinates of E? And we'll have a look at it and see if you got the right answer. Okay, right, so length of GH. I've got to work with my picture. Can't not work with my picture. What is GH? GH is a vertical distance, which simply means that if I have this is 32, and I want to know how many units all the way to H, what must I have in order to find what that distance is? What would I need? I would need the y value at H. So it begs the next question. How would I find a y value on that straight line? How would I find the y value on that linear? Well, we've got H as the the point on the straight line, we've already worked out earlier that this x value here is -1. So can you tell me how to find that y value at h? I'm sure you've got that. You would have to take that x value at h and find out what the y value is by substituting that -1 in. And by having that y value there as, let's say, it's got to be less than 10, let's say 8, then I'd be able to work out what that vertical distance is, because vertical distances are found by taking the difference in the y values. That's all. I mean, you're measuring it with that vertical number line, the y-axis. So all you have to do is have both y values to find a vertical distance. Okay, so let's go and do that. So let's recap. What have we got so far? We've got that x of g is equal to -1, and we did that by symmetry. So whenever we use symmetry, you need to alert us that you've done that, because we've used symmetry of the x-intercepts. Therefore, the x of h is also -1. So to work out the y of h, we would find out what is, no, that wasn't f, the function value g. So we'd have g of -1 would be equal to 2x plus 10. So we've got 2 times -1 plus 10. And I'll just write up here so we haven't lost track of that g of x was in fact given as 2x plus 10. Every time we're working out the y value, it is known as the function value. So the function value of -1 is 10 minus 2, which is equal to 8. So we are saying that point H is a point -1, 8. We're also saying that point G is -1, 32. So therefore, GH must be the difference in the y values, and therefore that's equal to 24. So GH as a vertical distance. Okay, so vertical distances, it will happen for that same x value. So if I've got the x value, I can just substitute into both functions to get out what my y values are, and then I just use that number line to measure off that distance from 32 to 8. Okay, great. So now we go to the horizontal. We need to find out how big is the horizontal. So you need to work out horizontal distance. Same thing, but using the x values. So we now have, okay, but something else they tell us is that this value here is 60 units. Now, what we have to say is, yes, that's great. I see that measurement, that's 60 units. We've got to connect. How are we going to connect that 60 back to the algebra? Because there is always a connection between the picture and the algebra. Got to always link it. If I'm doing something algebraically, I'm thinking, what's it doing on the picture? If I'm working on the picture, you've got to connect it back. What's happening with the algebra? Okay? So let's see. How would you relate point J and point L? Well, can you see that to get this vertical distance, remember we've just worked out that vertical distance, we've said it's a change in the y values. Same thing. Vertical distance on a graph is always the difference in the y values. Always. Just worked out, calculated it. Now we're using it in reverse. We're saying, you know what that vertical distance is. Go and find out what the x is. Right, so we're going to use that knowledge that we have that the distance of JL is 60 units. That means since it's a vertical distance, you have the y of j minus the y of L has actually given you 60. Okay, but now that's how I'm making sense of it. I'm telling you it's the difference in y's. I'm writing it as a difference. You still got to go back to the algebra and say, well, what is y of j? algebraically. Y of j is a function value, so you've got to relate it right back to the function. So we go back to the function. There it is. That's the y value in that form. Because I don't know what x is there, I have to take that whole function. And that's my y of g. So I'm going to take the y of j, which is minus 2x squared minus 4x plus 30, and I'm going to subtract my 2x plus 10. When I do that, I get a value of 60. Now, I just want to check that our signs are correct. Otherwise, we might get ourselves into a jam. Yeah, minus 4x. That's great. All right. So now I get minus 2x squared minus 4x plus 30 minus 2x minus 10 equals 60. Right, and guess what? We're back to solving another quadratic. What's grade 11 all about? Solving quadratics. In your sleep as well. Minus 2x squared minus 6x. 30 minus 10 is a 20, and a 20 minus a 60 is a minus 40. I hope you're checking my arithmetic there, then that you're happy. If something's gone wrong with my arithmetic, please post it on Facebook, okay? Right, so we divide by minus 2, so we get an x squared. Divide that by negative 2, we get a 3x. And then a minus 40 divided by minus 2 gives us a positive 20. Right, divide by minus 2, divide by minus 2, divide by minus 2. I'm not really happy with this. This is 20 minus 60 minus 40. 5 and 4 and 10 and 2. Divide by minus 2, we're going to get an x squared plus a 3 plus a 20. Okay, I'm going to work with this, although I'm not too sure that that's something's not gone wrong. Let's just go back here. Plus 30, 2x. Okay, let's do that. Let's take a quick break and come back in a moment.
All right. So guys, I hope this has been very helpful and you guys have been paying attention. Guys, make sure you don't go anywhere. If you're going to take a break, you literally have this time to go and do whatever you need to do so you don't get distracted, so you can get right back here and get back to working. But for now, we're going to see you after this break. Welcome back, Mindsetters. I hope you had a nice little break. Make sure that you got your snacks and whatever you need to do. So this last segment is really jam-packed, so make sure you don't move or go anywhere. And pay attention. And yes, keep posting if you want one of these, and a calculator and a labeler. But for now, I'm going to hand straight back to Dina. Dina, take it away.
Thank you, Ty. Well, we're going to go back to that question we were busy with. Let me just remind you what it was all about. We had a parabola, we had a straight line, and I said to you, why don't you try and work out what the coordinates of point E are while we're busy with the other questions. So if you've got an answer, why don't you post it, because in a minute or so I'll be working through that solution with you. But for now, let's go back to finding what OK is when we're given the length of JL. Now, in theory, you should have that picture with you all the time so you can be double checking. And look what happened. We said that y of j minus y of l is how we would get that distance. But I never looked at the function. I didn't ever look at that. It was y of g minus y of l. And so earlier on, I actually chose to work with a parabola minus a straight line, which wasn't going anywhere. So we took a quick break. I had a relook, and I figured out correct theory, but incorrect application. So let's go and fix that, okay? So it's very good to have the picture with you. So there's y of j minus y of l, but this is not y of j. There's y of j, and there's y of l. Okay, so we're just going to get rid of all this, and we're going to say it's got to be y of j, which is my straight line. So I'm going to write it here as it's my straight line's y minus the y of the parabola. And that's what's equal to 60. So y of the straight line was 2x plus 10. And y of the parabola was minus 2x squared minus 4x plus 30. And that's all equal to 60. So we've got 2x plus 10 plus 2x squared plus 4x minus 30 minus 60 equals 0. So we then have 2x squared. The 2 and the 4 make 6. And the negative 90 plus 10 makes a minus 80. So we've now got x squared plus 3x minus 40. That's a lot better because we've now got an x of plus 8 times the x of minus 5 as equaling 0. So we get an x of minus 8 or an x of 5. And again, we're making choices. Which of these x's is suitable for where we are? We are on the right-hand side. We're in the positive x side. So therefore, k must be 5. And so we've got this value here as 5. Makes sense. It's a little bit further away from the 3. And therefore, OK must be 5 units. So this value over here was 5 units. All right. So let's quickly look at E. E is the intersection. So it's where the y values are the same. So let's go down and quickly work out to see who the bright sparks, who the bright mind setters are today, and see who got it right. So always write down, always tell your teacher what you're doing. So at E, the y of, let's just get rid of, oh, dearie me, let's just undo that. So y of f would be equal to y of g, which means your minus 2x squared, your parabola's y value, would be equal to your straight line's value. So it's 2x plus 10. And now we're just going to solve. What are we going to solve? A quadratic. What's grade 11 about? Solving quadratics. So you've got to try and practice those and be really fluent and flexible with those quadratics so that you can have other time in your exam for thinking about other things. Right, so we've got a minus 2x squared. We've got a minus 2 that comes this side. We've got a 30 minus a 10 is plus 20 is equal to 0. Divide by negative 2, we get an x squared plus a 3x minus the 20 equals 0. Okay, so 5 and 4 and minus 2x squared minus 6x, 30 minus 20. Right, so let's just fix the arithmetic. Minus, okay, x squared plus 3x minus 10 equals 0. Divide by minus 2, yay. So we've got x minus 5, or rather plus 5, and x minus 2 equals 0. So x equals minus 5, or x equals 2. But x equals negative 5 is already where the other intersection worked. So this must be at 2. And how do we work out what the y value is at E? Well, we can either substitute parabola or straight line. Dumb move to go into the parabola. Too much work. Let's rather stick with a straight line. So let's go to the straight line and say if at E x is 2, then my y of E would be 2 times 2 plus 10, and that would give us 4 plus 10, which would give us 14. So therefore, E is the point to 14. All of you out there that got that this afternoon, well done. Very proud of you.
All right. So guys, if you were like Manda, who I saw actually got that one right as well, guys, make sure that you guys keep posting, keep chatting on the page, keep talking to each other. That's why the page is there for you guys. Guys, make sure you always keep writing notes. Make sure that you guys prep well in advance for your exams. And guys, I cannot stress enough, keep chatting to each other, help each other out. Instead of sitting there and saying I'm bored, rather say I'm going to help someone out today. But for me, I'm going to say peace out, and I'm going to be giving away these very soon, and I'll see you next time. Cheers.